Alrighty, thank you very much. My name is Paco, and I'm grateful to get to present. Let me check first. Can you hear me in the back row okay? Because I'll try to project, because I know we've got other noise coming in. Anyway, I'm grateful to present, and my hat off to Dave and Amy and Jen and all the crew here putting the conference together. I really, really love this conference. I am at a company called Senzing. You may not have heard of us. If you have a bank account, pay taxes, use a passport, etc., in the US, UK, Canada, Australia, etc., you've probably used us. We'll go through some of the use cases, we'll talk about this, but we work in an area called entity resolution, and I'm going to be talking about really the context of anti-fraud and where we're seeing a lot of uptick now in AI applications in the fraud space. So just briefly, I studied AI formally in grad school at Stanford many years ago, and I got to work with some famous people. Doug Lennett was my advisor. I got to work with John Hopfield, who shared the Nobel Prize for deep learning. A lot of fun. Eventually, I got pulled in by some friends on a little project and started using it early. We now know it as Amazon Web Services. And I led a team that fixed Hadoop so it would run efficiently on EC2, and then helped out with some of the other services like Elastic MapReduce. And because of that, I got pulled into Berkeley to give a guest lecture. And in the audience for my lecture were graduate students who, just a little bit after that, would found a little company called Databricks. So they called me back a couple years later, and I was on exec staff at Databricks back when we all fit in one room. On and on, it's been an interesting career. I've done a lot of work in contracting for DoD, Defense and Intelligence, and these days I'm at Senzing, where I lead more in the graph practice area, which is also very much where downstream we have the AI applications. So I want to talk about investigative graphs, just as an area of use cases that we see related to anti-fraud especially. And there's a lot of great popular media. If you haven't seen it, certainly the books coming from Oliver Bullough or Ann Applebaum, Carol Cadwallader, etc. Really fantastic investigative journalism. You've probably heard, how many people here have ever heard of Panama Papers? So a lot of that. Down in the corner, there's something called the Dark Money Files, which I highly recommend if you want to learn how to become a money launderer, but also what really goes on at banks in addressing risk. I'm going to focus on one use case in particular called the Azerbaijani laundromat. This is a really famous case. Frankly, it's fascinating. We could talk about this all day. There were some elite families in Azerbaijan who were purchasing weapons from Russia, but then getting kickbacks under the table. They were taking that money plus money that was stolen from the Azerbaijani state. They were funneling it out through about 500 shell companies, and eventually going out and bribing officials in the EU, buying condos, etc. So it was $3 billion over a period of about 3 years. But if you actually look, the branch of the bank, Danske Bank had acquired a Finnish bank, they had just acquired an Estonian bank, and that one branch subsequently was found as an estimate of 800 billion euros of money laundering during just a space of a few years. The Russian government actually sent a trial balloon out twice. After the 2009 financial crisis, they contacted regulators in US and EU and said, hey, we think this branch is doing something weird. And after the financial crisis, regulators were like, hey, that branch, they've got a lot of capital, they don't have a lot of overhang on loans, they're great. And so Russia did that twice, and then afterwards they were like, Spasibo, my drugi, ni za što, and they turned on the pipes. And so like 4,000 non-resident accounts pushed through literally hundreds of billions of euros of money laundering. So we'll take a look at some of this data a little bit later and show some investigative approaches with graph technologies, and also the scope of the problem for where AI apps come in. And in general, if you're not familiar with this space, there's an estimate currently of $3 trillion a year, and that's just for B2B money transfers. We're not even talking about other forms of dark money. But the fact is that violent crime is down and fraud is going through the roof. If you look in UK, it's now more than 40% of all crime is fraud. Just because it's simpler to go out and overtake somebody's bank account, a lot less risk than like pulling a knife on somebody and asking for their wallet. And the problem that we're really addressing here is that traditionally there aren't a lot of computing tools to address this problem. I mean, there are anti-money laundering tools, and we work with a lot of these vendors, but the scope of the problem is larger. And typically we're talking about very large criminal networks. And to paraphrase John Lambert from Microsoft Threat Intelligence, defenders think in lists, like checklists, but attackers think in graphs. And as long as that holds, the attackers win. Because the graphs, the networks are being used to obfuscate the crimes. And so what we'll be looking at here is how can we go back and recover that by using graph technologies, using artificial intelligence applications downstream. There's a kind of schema that we see repeated. I'll be building on this theme, but the idea is you typically have three components of data. You've got risk data, which you're probably bringing in from a data provider, and that's an extremely important part of this. And then on the right side, you've got event data. That's like your transactions, log files, et cetera, but it's usually very confidential. In the middle, you've got some kind of link data that connects it together. So this is a talk from some friends of mine, Christoph Williamson, Boris Gazowski, one of our colleagues, and Friedrich Lindenberg. And Friedrich showing this model. For example, on the risk data, there's an open data source called Open Sanctions, and they put together almost 250 different data sources worldwide, looking at people who are politically exposed or known for being convicted for fraud, et cetera. Where are the risks that have been flagged? So I'm going to show some tutorials using this. And then for connected data, there are a lot of great sources, open corporates, et cetera. But certainly like open ownership is really interesting for looking at ultimate beneficial owner. So looking at the trace across companies, who owns what, where are the shareholders, where are the directors, et cetera. That's usually where a lot of the obfuscation happens. And then the event data category is one that's a lot harder to get. Usually this is extremely confidential data. There are some examples, which is why I'm illustrating the Azerbaijani laundromat, because in this case, somebody working at the bank noticed a company called Lantana Trade. Anybody heard of Lantana Trade? It's the investment vehicle for the Putin family. And so when the guy at the bank saw he was handling that, he knew he was in trouble. And he leaked 17,000 records to OCCRP, which is what I'll use as a basis for some of the stuff we're showing. Okay, so entity resolution is what we do at Senzing. And it's very nuanced. It's actually a very hard problem, a lot more difficult than it may seem on the surface. The basic idea is that if you're in business, you have some records, some structured data about identity. It's probably somewhat fragmented, but it's there, it's in your database. It's about your employees, your contractors, your customers, your vendors. And you have those records because you have to if you're going to file your taxes, right? If not, IRS and HMRC and RevCan will want to have a conversation. So the problem is that even though you have your customer databases with identity ground truth, you're also, because of regulatory compliance, you're going to have to bring in data from other sources. If you're a bank, you're probably buying data from Dow Jones, Moody's, Sayari, et cetera. And you want to be able to find a consistent footprint, especially for the people and the organizations in question. You want to find the consistent footprint of them across all the different data sources. And this is a really hard problem because if you're at a bank, not only do you have your customer data, but then you also have other data systems that might be about, loans that are going across. You may have correspondent bank data coming in because of wire transfers. The data is very fragmented. But getting the identity right is important because if you mess up identity for people and organizations, that means people get denied loans, they get denied medical claims, they may be blocked from being able to vote or use their passport, et cetera. And when people and organizations get their identity messed with, usually they pull out their lawyer. So you want to get that right. And what we're talking about is where you want to take multiple sources of data, pull off different PII features, name, address, birthday, tax ID, et cetera, and be able to essentially triangulate on those PII features across the different sources. So to illustrate, don't know if you can see, but there's, in the diagram on record-to-record matching, there's 3 records. So there's Bob Smith II, Robert Smith Jr., and then there's Bob Smith with an alias, Bobby Jones. And if you're just looking at record-to-record and trying to stitch them together, I guarantee that will fail. That's where the problem comes in, and that's also what the fraudsters are trying to leverage, is the fact that if an analyst has to look record by record at thousands of records, they will not pick up the linkage. So instead what we're saying is take more of a holistic view, look at these different features across the different data sets, and then triangulate on them. And so what we produce is almost like an overlay of here are the entities, and here are the records they point to, and these are the pieces of evidence that justify that. And that's really the appropriate way to do the identity management, because then you've got an audit trail. You can prove why decisions were made based on evidence. The problem, though, is that it's not just a matter of like fuzzy string processing, like we'll see. It's really a matter of doing fairly complex work on names and addresses, et cetera, because you have so many cultural artifacts that go into it. So I'll illustrate some of them. As far as origins of the company, I'll scoot through this real quick, but how many people have ever seen a movie called 21? Stars Kevin Spacey. So at the end of the book and then the end of the movie, they're talking about new technology coming in, they're all gonna get busted, and then they all get busted. That was us. So we were kind of the bad guys in the movie, but that was the technology. This company started out in Las Vegas, working in the casinos, working at fraud in the casinos, and then was acquired by IBM and then spun out in 2016. And here's a slide from way back when, working in the casinos. You know, the idea is that you might have a no-fly list of people who are in organized crime. If they walk into the casino, if they're allowed back in, the casino can lose their gambling license, which would shut down multi-billion-dollar operations. So you have to look for these people, but they're coming in under all kinds of aliases. They get an apartment next to somebody who maybe is on staff, they get to know them, and they work out a deal. When we first did this demo, there's a story. We first did this demo, and there was a guy who was like at the top of the list in organized crime, and they were trying to block him, and they noticed during the demo that he was having lunch with the DBA for the casino, and so during the demo they were like, "Thank you very much, it's a great demo. Excuse us, we've got to take care of something. We'll be right back." So that's the kind of thing that goes on. It's very non-obvious relationships that you're trying to find footprints across the data. And I'll scoot through here, but here's an example of tradecraft. We call this channel separation. Somebody on the left side is a known money launderer, and then they go into a bank and they start opening different accounts to substantiate a different identity, and their PII drifts. So every time they open an account, something changes, but just slightly, enough to slip in under the wire. And then eventually, in the middle, you've got a new account that's being opened that has basically a different identity. So the idea with the entity resolution is to be able to find the linkage here, find the subgraphs, the evidence to show, actually this new account, it's a known money launderer, he's on your risk sanctions list, you've got to take action. And it's really hard because the edge cases are the value. So I studied Arabic a long time ago. My pronunciation is awful, so my apologies. But if you have this individual, Abdullah Qadash, and if I translate from Al-Luqat al-Arabiyya into English, depending on the dialect, that translation could go 5 different ways. If he's made a pilgrimage, he might have a prefix like Al-Hajj. If his parent is famous, he might have a suffix like Bin Amir, and then he may have a nickname, Abu. And so already, just with this one name, there's all these different variations. You have to understand the culture before you can really parse the name. And if you're looking at records that have people in Russian, in Arabic, in Korean, in Italian, et cetera, trying to find where these merge together becomes inordinately difficult. On the other hand, look at the one at the bottom. If you've got 2 names, John R. Smith and John E. Smith, they're only 1 letter apart. But if you think about voter registration, these are different people. Right, so how can you separate this apart with awareness about the cultural implications? So we support 80 different globalizations across the world, and we work with linguists, cultural experts to really understand how can we do matching on names and addresses. Here's an example. I am not a customer, but I know where this is in Singapore. It's a nice part of town. This, if you don't know, actually shows up in a lot of reports about bribery. But at the top, you've got different conventions. In Singapore, you've got Malay, Chinese, and British culture. And so you've got abbreviations for addresses from each of the different cultures, and they mix and match. So the top two are the same business, but they're completely different strings. And then down at the bottom, you've got another representation for that same business and one of its neighbors, and they're only 2 letters apart. So if you look at doing things like string edit distance, it falls apart. You really have to do substring parsing and understand the cultural conventions, and not just translation, but really understanding what pieces will match up. And of course, different kinds of languages, of course, get much more complex. So to do integration with this kind of technology, you call the SDK, it's JSON in and JSON out, and I'm going to have to move quick. Integration, we've got SDKs in Python and Java and .NET, and really it's like 3 lines of code to integrate. You probably want to think of more of like a streaming data case where records are coming through. One of the things we do is we handle really large scale with low latency. So you may have billions of records of different identities, and when a new record comes in, you want to make decisions about merge or disambiguate within millisecond SLAs. So it's very complex. And usually buy to build is such that you can do a little bit of this work building it out, but then you find there are a lot of nuances. Again, the edge cases are where the value is, and understanding the different cultures across the world that are represented in the data, that's the hard problem. And usually that takes years to build out. And I've been in a lot of those meetings. So there's a Forrester report that just came out, and I'm going to scoot through this to get to the AI parts more quickly. A lot of good logos here of our different partners that we work with and different data providers in particular. And we can talk a lot more about this, but the data providers are really the superpower in this area. What can you gain by bringing in multiple of these, merging them together? So I work in knowledge graphs especially. And I think Abhishek Nagaraj had a really good quote that data is an imperfect map of underlying entities. So any data set, there are entities and relationships in there, and it's really our job to pull out the non-obvious relations. And another way of saying this is that when you do entity resolution on different data sets, you are generating elements to build a graph. And that's how we look at it, is you're generating entities, relations, and properties. So from your structured data, you can use this identity information to create kind of a backbone for how you build out a graph, how you bring in data from unstructured data sources. And I should explain, if you've done work in NLP, you've probably heard of NER, named entity recognition, and that is something entirely different. So named entity recognition is where you have unstructured text, and then you look at noun phrases and you use a classifier to provide labels. Entity resolution is where you look at structured text, and in particular, you're looking at where this consistent footprint is of evidence about identity for people and organizations. But the two get pulled together in terms of entity linking, and we'll show a bit about that. Here's some case studies I'll move through. This really illustrates more of the graph side. It's a typical pattern we see for anti-fraud. It's also even like in hospitality or marketing where you're looking for, say, your best customers, there's a similar design pattern. So the idea is, number one, use entity resolution to pull your data sources together, generate graph elements. Number two, use partitioning like Louvain or strongly connected components. So you take a large graph and break it down into subgraphs that actually mean something to an analyst. And then number three, you can use graph algorithms like centrality, basically PageRank, so that the people who are most connected within a subgraph bubble up to the top. And then number four, put it all through the case management tools that are being used in banks, intelligence agencies, et cetera. So here I've got some data from Open Sanctions and Open Ownership, and it's about a case of about a million pounds of tax evasion. There was a couple that were running Papa John's pizza delivery in South London. And anyway, he was convicted. But basically, if I just take the raw data, it's already partly connected. But when I run entity resolution, then it's more fully connected. And now when I run a graph algorithm like centrality, the person who's orchestrating all this bubbles up to the top. So you've seen Abbasin Badshaw. He's the person who is actually orchestrating all of it. He comes up in the middle. And again, this is like a four-step process that we see with graph analytics to sort of prepare the cases. And then you can have AI apps downstream to do more summarization and using different agents to pick out the parts that are very relevant for a particular kind of case. Also, there's the matter of audits and being able to provide evidence, because usually when you're talking about fraud, ultimately you're hoping to go toward an indictment, a conviction, you're going to have to go to court. How do you put the evidence together? And so you can think of going through a lot of screens, but this is where we really see a lot of uptick in terms of smart ways of summarizing and basically pulling out all the relevant parts for a particular type of investigator. This is where we're seeing a lot of the AI applications for our customers. I'll show some examples of this. And I don't have much time, but I did a set of articles here. When we talk about resolution, entity resolution, I want to be very careful. We are not using models for the identity management part. We do a lot of ML upstream to prepare everything to build out our entity resolution solution. And there's a lot of machine learning downstream. But the actual identity part, where you're matching, that has to be based on evidence. So this is a nuance. This is something that if you're not in the field, it's something you learn very quickly when you talk with customers. I've got a library. I just wrote this, put this out a couple weeks ago. It's called Senzing Semantics. It does a few things. One of them is to take the results of entity resolution and then represent it as a SCAS thesaurus. So we have a small SCAS taxonomy. So if you have semantic layer tooling or anything that's leveraging really these kind of semantic components, then we're basically representing it in the global standards. And the interesting thing there is you're creating basically a domain-specific thesaurus from your data once it's resolved. And that's very useful for LLMs because LLMs are trained on web data. They know RDF very, very well. Just real quick, Python to pull an example together, and then that's what a thesaurus would look like in SCAS. And so a thesaurus is something that tells you about synonyms and antonyms and sort of, what is a higher class or a lower class. But this is really useful for constructing graphs. It's also really useful for doing techniques like semantic walks, semantic expansion, like if you're doing really intelligent forms of graph RAG, or agents that are leveraging graphs. And there's another piece that we just put out last week. This is a sample application. Actually, I can tell you, both in financial services and intelligence agencies, something very similar to this is in production. This is based off of DSPy. And so we're getting text summaries that are tailored toward what a particular kind of analyst role needs. This is really important because when you talk with these fraud teams, they have a lot of overhead when they do like end of shift handoff to another team, and they end up spending hours per day writing reports. And so now we can start to use AI tooling to help smooth those handoffs and make sure that the pieces don't miss. But anyway, it's a really good way of making sense of all the audit trail too. And I know my time is almost up, so let me shoot through. Here's a recent Databricks integration we did, which was really good for streaming use cases. We have something based on structured streaming, and Catherine Nelson just built this tutorial for us. Here's an entity linker where you take entity resolution results, put them through LanceDB and Spacey to do smart linking of what you extract from unstructured data sources. And so here in the Panama Papers, you see the purple boxes. Those are part of the Azerbaijani laundromat where we're actually linking directly into the entity resolved results, just coming straight out of Spacey. And then to pull it together, here's an example of doing enhanced graph RAG. So this is being structured by the semantic layer, if you will. Entity resolution results go in as a SCAS thesaurus. That creates sort of a backbone for the graph. We're pulling in with entity linking. We pull in from multiple unstructured data sources, put it into a graph, and then we do semantic expansion, semantic random walks during the RAG component to be able to enrich what chunks are being presented to the LLM. Again, it's all based on DSPy, and here's a bit of an architecture diagram for it. It's all up on GitHub. But you can zero in on a part of the graph. And here you can see if I ask a question, it'll go hit the graph, and it'll expand out from where there are hits within domain, expand out there, do a random walkthrough, optimize that subgraph, and then come out with the chunks presented to the LLM to give you the response at the bottom. We've got a tutorial with Kuzu, which is a graph database, open source, out of Toronto and Waterloo. And Prashant Rao and I will be doing a masterclass about that coming up next month. And then to tie it all together, this is the Azerbaijani laundromat, actually based off of what Prashant and I are showing in our tutorial. This is the actual like forensic accounting of the money transfers, again, from Azerbaijan and Russian kickbacks going through all these shell companies. There's a technique called layering, which is where you basically shuffle the money in different shell companies. And then eventually the big purple nodes are where the money is all collected and withdrawn to be used to buy condos and cars and pay bribes and things like that. So this is an open source example of using graph algorithms for that kind of forensic accounting and then for flow analysis so that you can actually build classifiers, train them to be able to do this pretty much automatically. And overall, I'll just end up with saying a lot of this is about neurosymbolic approaches. Where we can really take hybrid of leveraging LLMs, leveraging embedding models, reinforcement learning, etc., but then also bring in what we have from the symbolic side, like with knowledge graphs, doing inference off that side, again, with us, with evidence-based reasoning, etc. And I do a podcast every month with graph experts, so if you want, check out what we're doing. And I think I'm a couple minutes over time, so thank you very much.